So this is going to be the third video where I've talked about law of large numbers. First video, wasn't dedicated solely to law of large numbers, but it was within some slides and I talked about what it was. And then your homework was to do a Google form. And then I did a follow-up to that and showed you the first round results, which are peppered in here as a reminder. Oh, hopefully that'll kick back on and stay on. Let's see here. No, we'll see how that does. Yep. Maybe it'll stay on this time. And then I showed you the results, and I showed that we were rolling a four-sided die. So the theoretical probability was that we would land on 1 25% of the time, 2 25% of the time, 3 25% of the time, and 4 25% of the time. And we weren't exactly right on that, but we were pretty close. So then I asked you to go out and do it 3 more times. And we didn't get quite to everybody doing it 3 more times, so we got a whole bunch. So the original 70 are in these numbers. I just added the new numbers to these. So let's see how they've changed since I've asked you to do it more. All right, in the first round, we had 70 times. Somebody did the experiment where they rolled a four-sided die. Well, it was rolled 10 times, so 70 times 10. That meant we had a total of 700 rolls. Okay. After the second round, the experiment was done 212 times, so now we have 2,120 rolls. So we've little more than tripled the amount. And actually, as I was creating these slides, somebody went through and did it twice. So I was halfway done, and then I had to go back and change everything, which is fine. It wasn't a big deal, but I just thought it was kind of funny. So this left side is always going to be the first 70, and then the right side is going to be the second time when we have 212 responses. So this is just everybody's roll number 1. So you can see this represents 70 rolls, and we don't have anything close to a 25, 25, 25. But if you notice, this 37.1, it went down, which means it got closer to 25%. This 18.6 went up and almost hit 25% exactly. 18.6, it was below 25%, it got bigger, so it got closer to 25%. This one, on the other hand, was at 25.1, and now it's at 23.1. So 3 of them got closer, 1 of them got further away. Okay, here these two were almost right at 25%, and they stayed right there. But look at how this changed. This 31% and 17% became 23.1 and 25.5. So the law of large numbers started to correct that and make it look almost like a perfect 25, 25, 25, 25. Now it's still not there, but that's only with 212 rolls. So you'll see when we get up to, when I combine all of them, how we got closer yet. All right, this one was the one that was way off, where we only had 8.6. That jumped all the way to 19.8, so it got way closer. Okay, this was 27.1. It wasn't that far away, but it went down to 26.9, which I know isn't a big change, but it still got closer to that 25%. This one got closer by 0.2. This one got way closer, from 38.6 to 27.8. Okay, I'm just going to kind of go through them and let you look at them, and you can see how the graph is getting closer to that perfect 25, 25, 25 on each of these. That big chunk got a little bit smaller. That small chunk got a little bit bigger. That small chunk got a little bit bigger. The bigger chunk got a little bit smaller. So again, law of large numbers is taking effect. Again, you can tell a big difference here. These two are way too small, these two are way too big, and they got closer to almost that perfect fourth, and fourth. Same thing here. Okay. Same thing there. Now this was our best one last time, and you can see that it got even better. This one landed perfectly at 25%. It's the only one to do that I've seen. This is an anomaly here. That was 24.3, and it went further away from the 25%. So these contradict. This one's a little bit out of whack compared to the other ones. Okay, and this one you can see that this huge green shape almost got all the way down to 25%. So again, theoretical versus experimental. Theoretical says, in theory, when we roll a four-sided die, we should land on each of them exactly 1 out of 4 times, or 25%. Experimental says, well, actually do it and then see what your results are. Law of large numbers says, complete the experiment in an enormous amount of times, and the experimental results will equal or become very close to the theoretical results. Again, this is why casinos make money. Okay, they have games. The probability that you lose is in their favor. Right, so you might come out of there winning $3,000 one night, but there are 10,000 other people that lost $500. So they made $47,000 or whatever. I don't know how good my quick math was right there. Probably not very good, but you get the idea. They just lost. You won with 3,000, but according to law of large numbers, you weren't the only one who played, so they ended up making way more money than that 3,000 they gave to you. All right, so 700 trials that first time. 25% of that would be 175. So we would expect to have a chart with the result of 1 was 175 times. The result of a 2 was 175 times. Now, of course, it didn't do that. In the second round, since 212 people did it, that means we have 2,120 trials. So 25% of that would be 530. Okay, there's the chart from the first time. Now remember, we said 175 would have been perfectly 25% of the time. We had 172, which was only 3 away, 181, which is only 6 away, 161, which was 14 away, and 186, which would have been 11 away. So if I go to the next table, it was supposed to be 530 for this 212. Notice that's the second round. That one, the first one, was only 3 away last time. It got even closer. Barely. It's only 2 away now. It's supposed to be 530. It says 532. This one was 6 too big. It's still 6 too big. This one was 14 too small. Whoop. It is now 14 too small. So these two didn't change. This one was, sorry, I'm bouncing around, probably making you sick there. This one was 11 too big, and now it's only 6 too big. So both of these stayed the same amount away, but again, that happened way more times, so it's impressive that it didn't get further apart, and this one got closer, and this one got closer. So let's look at our percentages. 24.6, 25.9, 23, 26.6. So only one of them is less than 0.5% away. It's 24.6. It's 0.4 away. This is 0.9 too big, 2% too small, 1.6% too big. If we look at the second round, only 0.1 too big, only 0.3 too big, only 0.7 too small, only 0.3 too big. We upped our results by over 1,400 trials, and our numbers got closer to that theoretical probability. That is the law of large numbers working in real time right there. All right, here's our pie chart with the 700 rolls versus our pie chart with the 2,120 rolls. And you can see, if you look at it close enough, you can see that this is closer to that perfect 25, 25, 25, 25 than this one is. Now you can see that that wedge doesn't go straight over, it kind of dips down a little bit. All right. So that'll be the last we do of that. I think it's kind of neat that you guys get to see that. It's something I wouldn't be able to do in class. So this kind of format actually benefited us being able to do that experiment, spend a little bit of time. And if we were to do it, and you know, I said, hey guys, go do it 10 more times each, and we would get those numbers above 10,000. I almost guarantee that this would say 25.0, 25.0, 25.0, 25.0. If not, it would have like 24.9 and 25.1. It would be really, really, really close, right? But we're not going to take the time to do that. I think we've kind of hammered our point here. Have a good day. There's no additional homework. I'll have a video and some homework for you tomorrow, though. All right, so be ready for a video. Be ready for some homework. Yesterday, you had a Google form to fill out 10 questions. Make sure you get that done. That's due this Friday by 10 a.m. See you guys.